For math today, we're going to start off with a combination card, so pay attention and see if you can figure these out. Are you ready? 5 plus 6 plus 8 plus 3 plus 2 plus 1 plus 5 equals. Did you get 30? It is 30. 4 plus 9 plus 8 plus 7 plus 8 plus 6 plus 9 equals 51. The next one, 5 times 5 plus 5 minus 5 plus 5 times 5 divided by 5 times 5 equals. I feel like that was a hard one. Did you get that? Did you get 150? Okay, the next one, 6 plus 5 plus 5 plus 2 minus 3 times 4, think of the clock, minus 2 divided by 1 equals 58. 58. Next, 12 plus 6 times 5. Ooh, that's going to take a while. You might need to write that down. Plus 5 plus 3 divided by 1 plus 8 plus 6. That was definitely the hardest one, and that was 112. 112. Next, 7 plus 2 plus 2 plus 2 minus 4 divided by 3 plus 5 plus 1 equals 9. Yes. 8, last one, 8 times 8 plus 8 plus 8 minus 8 times 2 divided by 2 plus 2 equals. Hopefully you figured out when you have a times 2 and then divided by 2, it just goes back to the number you were at, and so that was 74. 74. All right, tell me the Roman numeral for this. It is L, C, M, I for some reason I always get I and 1 confused. I, V, D, and X. Did you get those? Let's look up at the board now. M, C, 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 X, X, I, V. Do you know that number? 1,324. 1,324. L, V, I, 58. And M, 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 V, I, 3,006. C, C, L, X, X, V, 275. XLIV. Hopefully you said 44 and not 66. When you have the smaller number in front, you subtract it. All right, let's look at this right here. Now don't laugh. This was going to be one of our first times using this together, and you're not going to believe it because I just opened it up, but it looks so busted right now. So don't laugh. Can you tell what temperature this is? Now this is the Celsius side and this is the Fahrenheit side. You can see that the Celsius side says 32, 34, 36, 37, and then the Fahrenheit side says 98.6. Do you know what temperature that is? That is normal body temperature. You got it. Is that above or below freezing? It's definitely above freezing. Trust me, you wouldn't want a frozen body. Okay, let's look at this one. What's this temperature? This is, on this side, the Fahrenheit is 32 degrees Fahrenheit. On this side is 0 degrees Celsius. What's that temperature? That is, hopefully you said that is the freezing point of water. So that is freezing. All right, let's try, all the way at the top. Sorry. Okay, it is 200, oops, I gotta move that up. It's 212 on Fahrenheit side and 100 on the Celsius side, which is the boiling point of water. Is that above freezing? Definitely, definitely. Now, let's look at some decimal fractions, and I want you to give me the decimal, okay? 9/10, which would be 0.9. 6/10, which would be 0.6. 7/10, 0.7. 3 and 7/10, 3.7. 4/10, 0.4. 4 and 9/10 would be 4.9. 2 and 3/10, 2.3. 1 and 1/10, 1.1. 5/10, 0.5. 1/10, 0.1. 2/10, 0.2. 3/10, 0.3. If you had 300ths, what would that be? 0.03. Remember, you can add as many zeros as you want after, and it still stays the same value, but if you put them before, it makes them smaller. Like if you put a 0 in front, 0.09, it'd be hundredths. If you put 0.009, you'd have thousandths, tenths, hundredths, thousandths. Okay, I can tell that you guys are doing well over there. Now, we are going from that to a speed drill. So right now, I want you to take your graded speed drill for our lesson, which is 148. So graded speed drill 148, you have 5 minutes, and then come back on, and we're going to learn about geometry. You guys, it is lesson 148. We have 170 lessons. So I was looking at math, and we only have a few concepts left. Basically, we have this concept. We have shapes tomorrow. We have perimeter and area, and everything that goes with perimeter and area. And then that's pretty much it. Everything else will be reviewed for the rest of the year for even our final exam. We actually have a math exam. It's 4 pages long with all the formulas and different things. But don't worry, you'll be ready for that. But we're going on to our geometry lesson for right now, our introduction to geometry. Let's look first at our line graph, something that we do know. Our line graph, what do we do when we have our line graph? You're right, we plot the points. We plot a point, and so a point can be placed anywhere on a grid. And a point can be placed anywhere. And so our first thing that we're going to learn about today is this is called a point. This is not a, you wouldn't refer to this as a dot in math. This is referred to as a point. What's the point? There you go. There it is right there. This is your point. Now, if you have 2 points and then you connect them, you now have a line segment. All right, so if we took 1 point and 1 point and we brought them together, boom, now we have a line segment. This is 2 points that are connected. This is your line segment, and you can see this in your book if you are following along with me. Now, our next one, I'm going to keep this one up so you can see. This is a line, and this is a line segment. Can you notice the difference between a line and a line segment? You might have said, oh yeah, one has arrows and one has dots. That's right. A line segment has a beginning and an ending point. A line has no beginning and no end. Almost like God. He has no beginning and he has no end. So this is a line, and this is a line segment. A line can just go on forever. No beginning point, no ending point. We put arrows here on each thing to say it goes forever in this direction and forever in this direction. Kind of reminds me of how the Lord says our sins are as far, when we ask Jesus for forgiveness, they're as far as the east is from the west. So far hath he removed our transgressions from us. And I'm thankful for God's forgiveness. And I'm thankful because when you have east and west and they go and they're never going to meet again. So we have our line segment. These are with our two points connecting. Then we have our line, which goes on forever. Our next one I like to think of like a sun. And so this is called a ray. So you can notice it has a beginning point, but no end. I like to think of it like a sun. Sun, and you know how a sun has rays, so you have your point, and then you have your ray, okay? So this is what our sun ray. So this is what, hey look, we're gonna make a bunch of rays. Okay, so, that looks scary. A ray is something that has a point, but no end. It can go on forever. So this is our ray. Next, if we have two rays that meet up, we now have an angle. If we have, so a ray is a point, and then a line, and then we have a point and then a line. Look what we have right here. This is an angle. Okay, so if we have two rays that meet up, now we have an angle. This is actually a tiny angle. We call it cute because it's so cute. It's actually called acute angle, A-C-U-T-E, which we're not learning right now, but you'll learn this later. This is called an acute angle, but you just need to know it's an angle. Now, if you have one that's at a 90-degree angle like this, I'm not calling you a loser. This is called do you know what this one is called? It's called a right angle, okay? Because you can make a square in here. So right angles are ones that you can make a square corner like this. This is your right angle where you can make a square right there in the angle. So this is just a regular angle. It's actually acute, and this is a right angle. Now, oh look, this reminds me of this emoji on your phone with the two dancing sisters or two dancing twins. So if we have twin angles, we have the two dancing queens right here. These are called congruent angles because they're twins. Look at them. They're exactly the same angle. They are congruent. And they have angles with the same amount of degrees. Oh no, we have two lines that have crossed. If we have two lines that cross, we call these intersecting lines. Intersecting lines are lines that have crossed at some point, okay? So this would be an intersecting line because they're two lines that have crossed. Now notice, do you see what these are? Yeah, you have your right angles there. If we have right angles there where we can make a square, a perfect square, we call these perpendicular lines. So these are perpendicular lines, but I mean they also intersect at some point, so they are also intersecting, but these are perpendicular. And then now for the saddest story ever. These are our parallel lines. This is the saddest love story ever. They grew up side by side forever and ever, but they'll never meet. The two will never meet. These guys have met perpendicular and they've crossed it, but these guys will never meet. Meaning that these will go on straight forever, but they will never at one point cross each other. All right, let's do a quick review to see how well you remember these. Yes, saddest story ever, the parallel lines. You have right angles, so these are perpendicular lines. Intersecting lines. When I think of this, I think of like when you're at a intersection on the road. When you're at an intersection, you might be parked here. There might be someone over here facing you, and then you have a car over here and a car over here. You may have a four-way stop. It's where everybody comes together, and then they stop right at the light, right? You can't have everybody coming at once, otherwise you're going to have an accident. So this is your intersecting lines, just like an intersection. This also looks like railroad sign. Have you ever seen the railroad sign like this? But these look like railroad tracks. Okay, now next. Oh, the twins, the congruent angles. This one, not calling you loser, but this is the right angle, right? This is just a regular angle, but we call it an acute angle because it's smaller than 90. Anything smaller than a right angle, like the 90, we will call it acute angle. You'll learn this later. Anything larger than a right angle, we call it obtuse, okay, because it's huge. This is, oh, did you remember of the sun? This is a ray. This is a line. This is a line segment because it has the 2 points. And this is a point. How'd you do? Well, we'll see because you're going to do page 267 right now. Turn in your book to page 267 and you're going to label A through H. Okay? All right. What is A on section 1? A is like the sun. It's a ray. Has the little sun and then it has a ray going out. What about B? Boop. It's a point. It's a point. C has 2 points that are connected. It is not just a line, it is a line segment. Did you get that? D is an angle. Bonus points if you knew it was acute. E is a right angle. F is, like I said, when you're on the road, you have intersecting lines, roads that cross. And it's very important to stop and look both ways because you don't want to cause an accident. G is just a line, but it's not a line segment because there's no points. No beginning, no ending. And H, parallel lines. They're just like very close, so close, but so far. Number 2. I think you guys did awesome on those. I can bet that you did amazing. Section 2, write true or false in the blank. A, are those congruent angles, true or false? Yes, there are 20s. So yes, that is true. B, true or false, those are parallel lines. Yes, they are. Besties that will never get to meet. Parallel lines. C, true or false, that is a right angle. Yes, it is because proof, you have that little square right in the corner. D, wow, they've all been true so far. D, those are perpendicular lines. That is false. Now, I know you might say, "Wait, I thought you said that they are intersecting line." Now, this is this might be tricky. I don't know, but intersecting lines are not perpendicular, but perpendicular lines are intersecting. You're like, "Wait, what? Stop confusing me." Perpendicular lines. Remember the definition of an intersecting line is lines that cross. So look, you can see that perpendicular lines cross, so they're intersecting. But what makes a perpendicular is that you have a square, the right angles. So intersecting lines are not perpendicular because they do not have right angles. Okay, now E, blank, that is an angle, true or false? That is true. Woohoo! We're already done with the front side. Now let's go to section 3. Pause. Let's see. You know what? I'll do it at the board. You do it at your seat, and I'll check. Don't worry, I don't have the Rona. I think I just coughed on something. I was wondering, do you guys still eat snack while you are doing math or no? Yes or no? I was just wondering that, but then I feel like you can eat whatever you want at your home. So maybe not. I love math, guys. I don't know how you feel about math, but math is just my favorite. I think about math all the time. But it's kind of impossible not to think about math all the time because whether you're trying to buy a video game or go shopping and buy your favorite stuff, you're going to need it. Okay, so I'm done. If you're not done, pause it, and then when you're done, come check it with me. Okay, so 3/5 times 11 would be, you just multiply across. You can't reduce. would be 33/5, which equals to 6 3/5. 3/8 times 4/5. You can reduce one or cancel and change the 4 to a 1 and an 8 to a 2. This is all a review, so I'm going through this quickly. If you have forgotten, send me a text or something, FaceTime me, but this is all stuff we've gone over many times. 3/10. This one I will go over for a second just to tell you. 4/8 times 22. What you do is you cancel and you make this a 4 and this an 11, multiply across and you get 44/4, which equals to 11, so your answer is 11. But another thing you could have done before even multiplying is you could have reduced 4/8 as a fraction and done 1/2 times 22 and then just canceled. Because you're not supposed to really cancel up and down. Now let's look at the last one, 3/5 times 42. Nothing you can cancel, so you multiply across, you get 126/5, divide that, and you get 25 1/5. The next section, Cassie practiced her music lesson from 3:30 to 4:15. What part of an hour did she practice? 3:30 to 4:15. Well, you should already know that your clock is in sections of 15s. Sorry, so I don't have Judy in here because remember we borrowed it from Miss Monroe. So you'll have to look over here at this horrible clock. She started at 3:30, so keep in mind that 3:30 is half past 3. So the hour hand would be between the 3 and the 4, and then the 30 would be directly on the 6. She went from 3:30 to 4:15. Now 4:15 is all the way over here. And some of you are like way ahead of us, and that's great. I'm just telling you how to figure this out. She went from 30 all the way to 4:15. So you can see that I'm going to show you the long way, okay? If you do the long way and you go from 30 all the way to 4:15 and count, you would say, okay, 5, 10, 15, 20, 25, 30, 35, 40, 45. That's 45 minutes have gone by. 45 minutes out of how many minutes? So that's your numerator. That's the part of an hour. And then how many minutes are in a whole hour? So parts to a whole and then the whole. Yeah, 60. So you'd have 45/60ths, which you could cancel and reduce. By 5, you would get 9/12. If you reduced it again by 3s, you would get 3/4. And that's your answer, is 3/4 of an hour. Some of you already know you would have thought, okay, I think of this in brackets of this is 15 minutes, 15 minutes, 15 minutes, 15 minutes, and this would have been 15, 30, 45, that's 3/4. And some of you might have been able to figure out already, okay, that's 45 minutes, 45 over 60, that is 3/4. And you can even prove this because if you think of a clock, a circle clock, like a circle fraction, and you just had 1, 2, 3 go by. Look at this fraction, you have 3/4. So it's just a bunch of random ways to do it. But I don't know how you did it, but hopefully you were able to get the right answer. B, Joseph played tennis with his big brother Andrew for 1 1/2 hours. How many minutes did they play tennis together? Now, you shouldn't even need anything for this. This should all be in your brain. 1 hour is how many minutes? Yes. And then what would be half of that? So then you have 1 whole hour has this many minutes plus the 1/2 of an hour, and add it together, and how much do you get? Right, that many minutes. It is 90, for those of you who are wondering. Okay, section 5, solve and check these equations. Pause your video, do your paper, and then come back and I'll tell you the answers. Okay, Remember, solve for what you know first. So when you solve for what you know, it's x plus 4 equals 24. And then you have to get rid of the 4. X plus 4 minus 4 equals 24 minus 4. X equals to 20. And then you check it, and 24 equals 24. B, y equals 0. And then you check it, 3 equals 3. C, n equals 12, and 6 equals 6. If you do not know how to do these, please call me and ask me to help you. I will help you. But we've been doing these for a week, so if you don't know how, just ask. All right, division, your favorite. So for division today, we're just going to go over the answers. You can pause the video, and then when you're done, check it. A, you should have estimated with 15, and when you count by 15s, your answer should be 181, remainder 11. B, 24 is very close to 25, so you know you can count by quarters, and you get 68, remainder 7. C, 42, you're using 40, but right away, remember how I told you when you're looking at a 42 into a 41, it's always going to be 9 times, it's like 1 less than the number. So it's 99, remainder 3. Okay, sections 7 and 8 should take you about 3 minutes or less. Do that and then check this. Okay, 10 and 7/10, 33 and 5/10, 80 and 5/10, 15 and 7/10, 180 and 0/10, 12 and 3/10, 8 and 4/10, 14 and 1/10, 9/10, 38 and 2/10. Hopefully you did well, and I'll see you tomorrow. Bye.